Hello everyone, today we are going to discuss the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 6A Paper 1 Code C and D. So let's start with the first section, students. So the first section, it contains 8 questions. The answer to these questions are in the form of single digit integers. So let's start with the first question, question number 21. An alloy prepared for experimental purpose contains aluminium, zinc, silicon and copper. When 1 gram of the alloy is dissolved in HCl, 896 ml of H2 is evolved at STP, leaving 170 mg of undissolved residue. The same 1 gram sample of alloy is dissolved in NaOH. It produces 1120 ml of H2 at STP, and in this case also some residue remains undissolved. The percentage of copper by mass in the alloy to the nearest integer is. So we've been given two different informations over here. So the alloy was first allowed to react with HCl. So we had 1 gram of the alloy. It liberated 896 ml of H2. Plus there was 170 milligram of residue. And the next information given to us is the reaction with NaOH. So the same 1 gram alloy, when reacted with NaOH, it produced H2 again, and the volume produced was 1120 ml, and in this case also there was some residue remaining undissolved. So we have to figure out the percentage of copper by mass in the sample. So if you look very carefully at the elements which are given to us in this sample, so we have been given aluminium, zinc, silicon and copper. So if you talk about these given elements and their reactions with HCl and NaOH, so we have aluminium, it will react with HCl, and we have zinc. So zinc will also react with HCl, whereas silicon and copper will not react with HCl. Now if we talk about this reaction with NaOH, so both this aluminium and zinc are amphoteric, so they will react with NaOH as well. And in addition to this, there will be silicon reacting with NaOH as well. Copper will not react with NaOH and copper will not react with HCl. So on the basis of this information, we can find out the number of moles of H2 evolved. So we have been given the volume. So 896 ml, it roughly converts to 40 millimoles. And if we talk about this 1120 ml, so this corresponds to 50 millimoles. So if we talk about the residue remaining in the first reaction, students, so this 170 milligram. So 170 milligram, it will consist of silicon and copper, as we had discussed that aluminium and zinc are going to react with HCl. So weight of silicon plus weight of copper is equal to 170 milligram. Okay, and if we compare these two informations, we can clearly see that the silicon, it reacts in the second reaction, whereas it does not react in the first reaction. So it means that if we figure out the number of moles of H2 which is additionally produced in the second reaction, we can then calculate the moles of silicon which was reacted in the second reaction, as the aluminum and zinc are common to both these reactions. So if we talk about the number of moles of H2 produced in excess in the second reaction, so we have the difference in moles of H2 is equal to 10 millimoles. Now we can figure out the moles of silicon reacted in the second reaction by using the equivalence concept. So we have the millimoles of silicon into its N factor. So silicon is going to get oxidized to its highest oxidation state, which is +4. Initially it was present in a state of 0. So its N factor is going to be 4. And if we talk about the equivalence of H2, so the excess moles are 10. And if you talk about the N factor of H2, students, so its N factor is going to be equal to 2. So this must mean that the millimoles of silicon is equal to 10 by 2, which is equal to 5. So now we can calculate the mass of silicon. The molar mass has been given to us. It is 28 gram per mole. So weight of silicon in the 1 gram alloy, it is equal to 28 into 5 milligrams, which is equal to 140 milligrams. So now, students, we have established that out of this 170 milligrams of residue which was remaining, 140 milligrams are of silicon. So this must mean that the weight of copper in the alloy should be equal to the difference of these two masses. So 170 minus 140 will give us a value equal to 30 milligram. So students, now we can calculate the percentage by weight of copper in the sample. So the total mass was 1 grams and the weight of copper was 30 milligrams. So this must mean that the percentage by weight of copper in the sample is equal to 3%. So students, for this question, we have to mark the answer as 3. Let us look at the next question now. Question number 22. Pentane dioic acid, which is also called as glutaric acid, was heated and the organic product obtained had a molar mass of M1. In another experiment, hexane dioic acid, which is also called as adipic acid, was heated and the organic product obtained had a molar mass of M2. We have to comment on the difference in the molar masses of these compounds divided by 5. So let us talk about the heating of this dicarboxylic acid. So the first acid which we have is the pentane dioic acid. So it is going to have 5 carbons in the main chain. So this is a pentane dioic acid. When it is heated, it is going to lose an H2O molecule. It is going to get dehydrated, leading to the formation of an anhydride. So we are going to obtain a cyclic structure in which there are 6 members present in the ring, which is very stable. So this is the major organic product which is obtained due to heating of glutaric acid. Now we can talk about the heating of adipic acid. So adipic acid is hexane dioic acid, so it is going to contain 6 carbons in the main chain. So now if we talk about the heating of this adipic acid, so upon heating, if we try and form the anhydride will have 7-membered ring, so which is not very stable. So in this case, there is a loss of CO2 as well. So upon heating, this compound is going to lose an H2O and a CO2 from it. So there will be the formation of cyclopentanone. So this is the major organic product which is obtained. The molar mass of the first product which was obtained is 114. And if we talk about the second reaction, the major product is cyclopentanone and it has a molar mass equal to 84 units or 84 gram per mole. So M1 is 114, M2 is 84. The difference between M1 and M2 is equal to 30. When it is divided by 5, it will give us a value equal to 6. So students, for this question, we have to mark the correct answer as 6. Let us look at the next question now. Question number 23. In the structure of I2Cl6 and Al2Cl6, the maximum number of atoms lying on a plane is X and Y. Respectively, we have to comment on the difference of X and Y. So let us try and draw the structure of these two compounds which are given to us. So we know that I2Cl6 is a completely planar compound. So the I, it takes sp3 d2 hybridization. The geometry around I is octahedral. There are 3 center 4 electron bonds present in the compound as well. It is the dimer of ICl3. So the complete molecule is planar, students, and all of these given elements, they lie on the same plane. So the value of X, it will come out to be equal to 8. Let us now talk about Al2Cl6. It is the dimer of AlCl3. So we have Al2Cl6. So this also contains 3 center 4 electron bonds. Okay, there will be 2 coordinate bonds present. Now, since there are no lone pairs over aluminium, this aluminium is sp3 hybridized. So both of these aluminium are in sp3 hybridization and the geometry around them have to be tetrahedral. So if we talk about this Cl, if we assume it to be coming towards us out of the plane, then this will be going away from us. Similarly, this will be coming towards us and this will be going away from us. Whereas the other 2 chlorine atoms will be on the plane as per the representation. So now students, if we talk about the total number of atoms which are lying on a plane, we can see that the aluminium and the terminal chlorine atoms are all lying on the same plane. So we have a total of 6 atoms which are lying on the plane. So the value of Y shall be equal to 6. So X is 8, Y is 6, and the difference has to be reported as 2. So for question number 23, we have to mark the answer as 2. Let us look at the next question now. Question number 24. A white crystalline solid X exhibits the following reaction. It is a binary salt. The second information given to us is that it imparts yellow color to the flame. So students, we have a very strong hint that the cation present in the binary salt is sodium. Sodium ions, they impart yellow color to the flame. Let us look at the third information which is given to us. Aqueous solution of X is neutral. It means that the cationic part does not take part in hydrolysis. So it is also the conjugate of a strong component. If you talk about the fourth information, on addition of AgNO3 to an aqueous solution of X, a yellow PPT is obtained which is insoluble in ammonia. So this is giving us a very strong hint that it is I- which is present in the compound as the anion. Let us look at the further information. They are going to clear our doubts. So the fifth information, it says yellow PPT obtained in 4 readily dissolves by adding excess of KCN or sodium thiosulfate. So it also gives us a hint that the anion should be I-. If we talk about the sixth information which is given to us, on addition of CuSO4 to an aqueous solution of X, the solution turns reddish brown and a white precipitate is obtained on addition of sodium thiosulfate. So this confirms the presence of I- in the salt, students. So we have cupric ions when they are allowed to react with the iodide ions. So what happens is this cupric ions get reduced. So we have the formation of Cu2I2 and we have the liberation of I2 as well. Now this I2, it reacts with the I- and forms the triiodide ions. So this is brown in color or reddish brown in color. And due to the presence of this triiodide ions, the solution becomes reddish brown. When this is allowed to react with sodium thiosulfate, the iodine which is present in this triiodide ions is converted into normal iodide ions and the solution becomes colorless, due to which the precipitate of Cu2I2, which is white in color, it becomes visible. Okay. So students, the salt which we are dealing with over here is NaI. Let us now come back to the question. So if the cationic element belongs to group number X and the anionic element belongs to period number Y in the modern periodic table, then the value of X plus Y is. So students, if we talk about the cationic element, it belongs to group number X. So sodium, it belongs to the alkali metals. So the group number which is equal to X will be equal to 1. And if we talk about the value of Y, which is the period number of the anionic element, so the iodine, it belongs to the 5th period. So the value of Y is equal to 5. And if we talk about the sum, it comes out to be 6. So students, the value which we have to report for this question is equal to 6. Let us look at question number 25 now, students. In the given compound, so we have been given 8 different compounds and the examiner seems to be interested in the total number of aromatic compounds in the given compounds. So it is told that the total number of aromatic compounds is X and we have to report the value of X. So if we talk about the first molecule which is given to us, so in this molecule there can be a polarization of the double bond indicated in such a fashion such that the carbon present in the ring, it gets a positive charge and the carbon just outside the ring gets a negative charge. So due to this polarization, the first compound, it becomes aromatic. If we talk about the second compound, it is a non-aromatic compound. There is no complete conjugation in this molecule. If we talk about the third compound now, this is also not aromatic. It contains 4 pi electrons. So it does not follow the Huckel's rule, which says that there should be 4n plus 2 pi electrons in the complete conjugation. If we talk about the fourth molecule now, in this case there is a 5-membered ring and a 3-membered ring which are attached with a double bond. So we can polarize the double bond present between the two rings in such a fashion that 5-membered ring gets a negative charge and the 3-membered ring gets a positive charge. So due to this polarization again, both these rings become aromatic. If we talk about the fifth molecule now, in this case also there can be a polarization. The polarization of the double bond towards oxygen and there will be a positive charge generated in the 7-membered ring, due to which it shall be completely conjugated and have 6 pi electrons in the complete conjugation. So this is also aromatic. If we talk about the sixth molecule, this is non-aromatic. It is non-planar because large rings or large 8-membered rings, they do not exist in the planar form. So this is not aromatic. If we talk about the 7 molecule now, so this is also not aromatic because of the presence of these 2 hydrogens over here. They do not allow the molecule to remain planar. If we talk about the last molecule, which is the 8th molecule, so we have a 6-membered ring. There is boron. Boron has vacant p orbitals, whereas nitrogen has lone pair of electrons. So this system is completely conjugated and it has 6 pi electrons in complete conjugation. So this also satisfies the Huckel's rule for aromaticity. So students, we have 4 molecules which are aromatic and the value of X has to be reported as 4. Let us look at the next question now. Question 26. The conductivity of a saturated solution of CO2 FeCN6 is 1.78 into 10 raised to power minus 6 Simon centimeter inverse, and that of the water used for making the solution is 4.6 into 10 raised to power minus 7 Simon centimeter inverse. The ionic equivalent conductivity at infinite dilution of CO2 plus and FeCN6 4 negative are 86 Simon centimeter square equivalent inverse and 442 Simon centimeter squares equivalent inverse respectively. If the solubility of CO2 FeCN6 at 25 degrees C in water is C, when 16C expressed in scientific notation is x into 10 raised to power minus y, then the value of x plus y is. So we have been given the conductivity of a saturated solution of this complex, and the examiner has also mentioned that the water used for making the solution also has to be considered. So if we talk about the conductivity of this complex, so the conductivity of the solution and the conductivity of water have to be used, and the difference between them will give us the conductivity of this complex. So we can have the kappa of the solution equal to kappa of the complex plus kappa of water. This kappa indicates conductivity. So we have kappa of the complex equal to kappa of solution minus kappa of water. So we can put these values to find out the kappa of the complex. So it is 1.78 into 10 raised to power minus 6 minus of 4.6 into 10 raised to power minus 7. So this will give us a value equal to 1.32 into 10 raised to power minus 6 Simon centimeter inverse. Now we have been given the ionic equivalent conductivity at infinite dilution. So we have been given lambda EQ naught or lambda EQ infinity of CO2 plus, it is equal to 86. And if we talk about the lambda infinity EQ of the complex anion, so we have FeCN6 4 negative. So it has a lambda equivalent equal to 442 Simon centimeter square equivalent inverse. So we can talk about the lambda EQ of the complex at infinite dilution. So it will be equal to the sum of both these numbers. So 86 plus 442, this is equal to 528. Now we can find out the molar conductivity at infinite dilution, students. We were dealing with the equivalent conductance. So we have lambda m, m is for molar. This shall be equal to the lambda EQ at infinite dilution into the n factor, and we can see that the n factor for this complex is equal to 4. So we have 528 into 4, which is equal to 2112 Simon centimeter square mole inverse. So now students, using this lambda m infinity and using the kappa of the complex, we can calculate the solubility of this sparingly soluble complex which is given to us. So we have lambda m infinity is equal to kappa into 1000 by C. So C is the solubility in this case. So this implies that the value of C will be 1.32 into 10 raised to power minus 6 divided by 2112 into 10 raised to power 3. Okay. So this on simplification will give us a value equal to 1 by 16 into 10 raised to power minus 5. So if we talk about the value of 16C, so the value of 16C will be equal to 10 raised to power minus 5. And when it is expressed in the scientific notation, it has to be written as 1 into 10 raised to power minus 5. So we can see that the value of x over here is equal to 1 and the value of y over here is equal to 5. And since we have to report the sum of x plus y, it will be 1 plus 5, which is equal to 6. So for question number 26, we have to mark the correct answer as 6. Let us look at the next question now. Question number 27. Consider the reaction. So we've been given this substrate which is allowed to react with red P in HI. The molar mass of the reactant is M1 and the molar mass of the product is M2. We have to comment on the difference of the molar masses divided by 10 to the nearest integer. So students, let us first figure out the product which will be formed. So we know that red PHI is a very good reducing agent. It is going to convert this carboxylic acid into CH3. So we're going to have the formation of CH3 in place of COH. Now if we talk about the ketone shall also be removed. It will be converted into CH2. And if we talk about this alcohol, it will also be reduced and a hydrogen will be added to its place. So this is the product which is obtained. Now students, we have to comment on the difference between the molar masses. So we can clearly see that the 2 oxygen have been removed over here and 2 hydrogen have been added. So there is a difference of 30 over here. If we talk about this ketone functional group which was present, so the oxygen is removed and 2 hydrogens are added. So there is a difference of 14 grams over here. And if we talk about the alcohol group, only the oxygen is removed. So there's a difference in molar mass of 16 units over here. So we can clearly see that the total difference in the molar masses is 60. So M1 minus M2 is equal to 60, and when it is divided by 10, the answer comes out to be 6. So students, for question number 27, we have to report the answer as 6. Let us look at the last question for this section. Question 28. If the total number of solutions which act as a buffer among the following is X, we have to comment on the value of X. So let us look at the options which are given to us. So option A is NaH2PO4 and H3PO4. So this is a buffer solution. It consists of a weak acid and its conjugate base. If we talk about the B option now, HClO4 and NaClO4. So HClO4 is a strong acid. The given mixture does not act as a buffer. If I talk about option C now, I have C5H5N and C5H5NHCl. So this is also a weak base, students, and along with the weak base we have its conjugate acid. So this will also act as a buffer. In the next option we have acetate ions and acetic acid. So this will act as a buffer. Acetic acid is weak, its conjugate base is relatively stronger, so they will act as a buffer solution. If I talk about HBr and KBr given in the E option now, HBr is a strong acid, its conjugate base when mixed with it will not act as a buffer. If I talk about Na2CO3 and NaHCO3, so this is a conjugate acid base pair, and Na2CO3 is a weak acid, so its conjugate acid along with it will form a buffer solution. If I talk about G, ammonia with NH4Cl, this is a buffer solution. Ammonia is a weak base. NaIHI, this will not act as a buffer. HI is a strong acid, so its conjugate base along with it will not act as a buffer. If I talk about KClHCl, this will also not be a buffer. And if I talk about the last option which is given to us, aqueous solution of borax. So if I talk about this aqueous solution of borax, so borax, when it is put in aqueous solutions, it will undergo hydrolysis. So I have B4O5 OH4 2 negative. When it is allowed to react with H2O, it forms BOH whole thrice and BOH whole 4 negative. So this is a weak acid and we have the conjugate base of the weak acid along with it. So this will also act as a buffer. So out of these given combinations, a total of 6 possibilities are there which can act as a buffer. So for question number 28, we have to mark the answer as 6, students.